All right, moving on to our next unit, which is on chapter 11, and it will be covering areas of all different kinds of shapes. So areas of four-sided figures, any kind of polygon, a circle, a semicircle. So what is area? So hopefully you will know what area is, or you feel like maybe you already know what area is. Perimeter. So what is perimeter? Recall that perimeter is the name given to the sum of lengths of the sides of a polygon. So perimeter is one-dimensional. You go around the outside edge of something, right? In a circle, the perimeter is called circumference. But around any shape, if you were to trace your pencil around the outside edge of the shape, if you were to walk around the outside edge of something, then you're walking the perimeter, or you're sketching around the edge, which is the perimeter. But what is the area of something? So a lot of you might remember, oh yeah, it's length times width. You might remember it's base times height. You might say, oh yeah, it's the interior of something. So area is two-dimensional, right? So you have a length times a width. That's why we always have units squared, units to the second power. So it's multiplying the length times the width, which is then calculating all of the area inside the shape. So if we have a square specifically, well, what do we know about a square? We know that the two sides of a square have the same length. If the two sides of a square have the same length, and we call that length S, then the area of the square would be S squared, or 1 squared. Right, so this is 1 square unit, right? If that unit was meters, then it would equal 1 times 1, which is 1 meter squared. We would have meters times meters, and m times m is m squared. Okay, what about for this? If we had 4 units, right, you can see 1, 2, 3, 4, by 4 units. Well, that's 4 times 4, so the area for that would be 16 square units. Which means, you can see it here, there's 16 boxes that are 1 by 1, 16 squares that are 1 by 1 inside a 4 by 4 square. What if these two figures are congruent? What's going to be true about their areas? They will be the same. Right, so if this is also 4 by 4, then the area has to be 16. If this is 4 by 4, the area has to be 16. So if two figures are congruent, then they have the same area. Goes for triangles, polygons, rectangles, whatever it is. Now, is the converse true? So what is the converse? Remember, the converse is when we switch these two parts of the statement. If two polygons or two triangles or two squares or two rectangles have the same area, then the two figures are congruent. So if two figures have the same area, then the two figures are congruent. Sorry, that's a little messy there. The two figures are congruent. So is that true? So obviously it's not, because it says draw a counterexample in the space below using our example of 16 square units. So can we make something that has 16 square units but is not the same figure? Well, sure. Hopefully you're like, ding, yes, light bulb went off. We can multiply 4 by 4 to get 16. We can multiply 1 by 16 to get 16. We can multiply 2 by 8 to get 16. And then, of course, we can do all kinds of decimals and fractions multiplied together to get 16. So what is my counterexample? Maybe my counterexample is a 2 unit by 8 unit figure, right? So we cut that into 2, cut this into 8. We would see that that also adds up to 16 units. So if 2 units have the same area, well, this is an area of 16 square units. Then the two figures must be the same, or congruent. Well, no, that's not true. these two figures here are not congruent, but they do have the same area. Okay, moving on. Second page. Well, how do we calculate the area? What's the traditional formula, right? So we said it could be length times width. You might have seen that before. But for this book, and to be consistent with triangles and all different shapes, we're just going to call it a base and a height. So the area of a rectangle is base times height. So what is the base? What is the height? Really, it doesn't matter, right? We can call this part the base. Some people like to do that because it looks like it's on the ground. So this would be the base, this would be the height. You just have to remember that the base and the height need to intersect at 90 degrees. But who's to say that this isn't the height and this isn't the base, right? It doesn't really matter. We could flip that, we could make it long. So this would be the height, this would be the base, or it doesn't matter how you look at it. As long as your base and your height, you're identifying them and they're intersecting at 90 degrees. Okay, so now that we have a formula for the area of a rectangle, it's easy to see why the area of a triangle is what? Well, if we made this a rectangle right here, right, and we split this rectangle with a diagonal, well, we now have two congruent what? We have two congruent right triangles. Both of these triangles are the same. Well, if the area of a rectangle is base times height, I just said this right triangle right here is half of the area of the entire thing. So therefore, to get the area, we're going to take the base times the height, but we're going to divide it in two because I'm not talking about this entire rectangle. I'm only talking about half of it. So base times height divided by 2, or probably base times height divided by 2 is what you'll see more often. Or 1/2 base times height, right? All the same. So if you're not sure how this formula was derived, why it's base times height divided by 2, let me know. Otherwise, I'm assuming you followed that idea there. Okay, so postulate. The area of a region is the sum of the areas of its non-overlapping parts. The sum of its non-overlapping parts. So if we were going to try to find the area of this, we'd add all the squares together that don't overlap, right? So probably the easiest thing I would do is I would take this big chunk, I'd add it together, right? And then I kind of start piecing stuff together. So I might take this square and get rid of it and put it up here and call that a square, right? Or this little piece looks like it could go here. This piece went there. And this little piece I might be able to get rid of and put there. And this little piece I would put there. So I would keep piecing these two together, and then I would count them all up, right? So 1, 2, 3, 4, 5, 6, 7, 8. This is 8 by 1, 2, 3, 4 by 4. So this entire space here is 32 square units. And then I would count these 1, 2, 3. This put together is 4. This put together is 5. This put together is 6. This put together is 7, and then 8. So this looks like this has a total of 8. I would do the similar idea down here, and I'd figure it out. Or I could separate it into shapes. Yeah, so I didn't figure this out down here. You should do it. Or I could say this is a right triangle, right? This is 2 units in height, and 1, 2, 3, 4, 5, 6, 7, 8 units across. So 2 times 8 equals 16. 16 divided by 2 is 8. So the area of this, which I approximated, you could see, so I did a good job, right? 8 square units. And how did I do that? We're just filling in all these little missing pieces here, putting them together. So down here, we said it's 8 units across, and then it's 1, 2, 3 units in height, because this is where they intersect at 90 degrees. So that's 8 times 3 divided by 2. 24 divided by 2 is 12. So therefore, I'm going to do 8 plus 32 plus 12 to get the total area, which is 52 units squared. So you could either count the squares by piecing them together, Or you could use your formulas we just learned, which is base times height for a rectangle and base times height divided by 2 for a triangle. Again, see me in class if you have questions or you're not sure what's happening. I think that's it for this page. So let's move on to our final page. So now we're moving into a parallelogram. The first area formula we will find using the area of a rectangle is the area formula for a parallelogram. Well, what is a parallelogram? Right? We said the opposite sides must be parallel to each other, right? And when you have a parallelogram, the opposite sides are therefore the same length. So the opposite sides are congruent. Well, if we do what we just did, or sorry, if we take that same strategy, I draw a line down here, I take this triangle, and I put it over here, it's going to fill in perfectly right here. And so then I eliminate this part, right? Ooh, maybe I can do this. I eliminate it with my white. And now I have this new one, and it's a rectangle. And what is the dimensions of this rectangle? Well, it's my base, right? Well, this little part here was this part over here, so I just moved it. So the base is the entire base of the parallelogram. And the height, right, this is my 90-degree angle here, is the height, which means it goes from the top to the bottom, but it has to intersect at 90 degrees. So I can construct a parallelogram into a rectangle. So the formula for the area of a parallelogram is still base times height. But remember, your height and your base must intersect at 90 degrees. So if this is my base right here, I could call this my base. So my height is right here. This is my height. Right? I would take this triangle and put it over here to make my rectangle. So this is my height. It intersects at 90 degrees. This right here is my base. Right? I could remove this, put it over here to create it. So again, you can look at it in different ways. How about down here? Find the area of the figure on the right. So how could we find this area? I highly recommend you just split it into shapes. So maybe have a little pause here, see if you can figure it out on your own. We all might divide it into slightly different shapes. So pause and solve on your own. Okay, so what did you get? We should split this. I would split it into a huge rectangle, and this is 6 times 11. So this is 6 centimeters by 11 centimeters, which is 66 centimeters squared. And then I would do my little triangle. So I have a height of 1, but what is this length here? Well, I see that this is 7, therefore this length here must be 4. Even though it doesn't look like that, remember your diagrams are never drawn to scale. So how do I know that's 4? Because the whole thing has to add up to 11. So 7 plus 4 gives us 11, therefore this is 4. So this is 4 times 1 divided by 2, so that's 2 centimeters squared. So 66 centimeters squared plus 2 centimeters squared will give us 68 centimeters squared. Notice I always have units. Notice the units are squared because we're talking about area. You need to get into the habit of labeling with the units and the proper exponent. So please make sure you have your answer of 68 centimeters to the second power, centimeters squared. Okay, let's try the second one. It says find the height of a parallelogram that has the area of 8.19 meters squared and a base of 2.1. If you want to try it on your own, go ahead and pause here, try it, and then come back and see how you did. Okay, it says the height of a parallelogram needs to be found. We know there's an area of 8.19 meters squared. We know the formula is base times height equals 8.19 meters squared. Well, the length, the base length, is 2.1. So I substitute that in for B. I divide 8.19 by 2.1 and get 3.9 meters. So I originally sketched this, 2.1 meters across the base. Then I didn't know the height, so then I solved it and found that, oh, it's a lot bigger than this. It's almost double the size. So I went back over here and I decided, well, I should sketch a more accurate picture of what that looks like. So 3.19, it's almost twice this size. This is 2.1. So this is a little bit better. That's it.